Hello, it's me, and I had a viewer request slash question regarding this puzzle here. This is from cubetwists. This is actually a 4x4. You can see the 4x4 underneath. So they just basically took a 4x4, then they put these little tiles on it so that it can be bandaged. This is bandaged as a 2x4x4. So this is, I guess, a cubetwist 2x4x4 bandaged 4x4x4. Cubetwists has come out with a number of bandaged puzzles that includes like the wall cube and other types of cuboid-esque bandaging of 4x4s or 5x5s. So the question that I got, which was actually kind of an intriguing question, is this comes from Akigas. I hope I'm pronouncing your handle name right. It says, Hi Super Tony Vivaldi. I have a question that I wonder if you could maybe make a video explaining the answer to. I was looking at the Twisty Puzzles Museum, and while reading about the 2x4x4 bandaged 4x4, it says this puzzle is harder or has added complexity to the solve than a straight 2x4x4, which is this guy over here. Due to non-laminar configuration the corners can then end up in. This same feature comes out of the Whit-Eaton 2x4x4 camouflage cube, as well as custom puzzles such as Trefum's 2x4x4 are both constructed out of bandaged 4x4s. One being extended and one being cut down respectively. These 2x4x4s constructed out of 4x4 differ from a true 2x4x4 such as the one you have video demonstrating by Ola Jansen, which is what this is, due to these non-laminar configurations, not owning either a bandaged 4x4 version, I'm going to make one day, or the one by Ola Jansen. I'm having difficulty visualizing what this means in a practical sense, and if you could maybe demonstrate the difference and show what is meant by non-laminar in a video, would be appreciated. So I don't blame you for not being able to visualize it, because I can't either. As a matter of fact, I'm not really sure I understand what they mean by this non-laminar thing, non-laminar arrangements. So I checked out the site, that Twisty Puzzle site, and on their museum, it actually says, actually Dad built this beautiful example for me as I designed it. It turns out there's an additional unanticipated layer of complexity in the solution. Each of the 8 2x2x2 cubelet corners, which I guess means these guys over here, these 8 corners, can be scrambled into constraint non-laminar arrangements, and each of these have to be solved before the cube is solved as a whole. These non-laminar arrangements demonstrate this cube, distinguish this cube from the ordinary 2x2, 2x4x4 cube. So the question is, what is meant by this non-laminar arrangement? I guess perhaps what they mean is that it can be rotated, that these corners here can be rotated in a way that these can't. My contention is this: I'm not really sure exactly what they meant by that. I suspect it has to do with the fact that this is straight on. These corners obviously look different from this corner, and that when you do maybe a 90-degree turn like this, what it does is it bandages the puzzle so that this is matched with this. If I do something similar here, like that, then that non-laminar arrangement maybe creates an issue over here. If I move this up, then this drags this over here, and I'm unable to do more. I don't look at that as any different from here. So, to be honest with you, when looking at this, I don't see this as any different in terms of the solve strategy or the complexity as this guy. So if anybody out there has more of an insight in terms of what's meant by that, well, what I'm going to do is I'm just going to go through a solve and a scramble of this puzzle, and my contention is that this is not any more complex than a 2x4x4. It's solved exactly the same. So for those who have this but don't have this, this will be a tutorial on how to solve this guy over here, and to those who do have this, I'll show you that I don't really see it as much of a difference. So to best solve a floppy cuboid, which is what this is, first thing I'm going to do is, as you look at it like this is well, likened onto here, almost exactly likened onto here. We got 4 over here, 4 over here, and then you've got 2 down over here. There's no extra pieces with that, like you had with the wall cube that you had to deal with bizarre and frustrating algorithms. So the way that I scramble it first is I just go ahead and do 180-degree turns like this. So I start the scramble off in as unbandaged a way as possible. This is Ola Jansen's puzzle, one of my favorites, in that it's fully proportional, really brilliantly designed, very stable, very playable. It seems kind of floppy, but, well, that's kind of what this is, floppy cuboid, so that stands to reason. Alright, so same thing here. I'm just going to go through 180-degree turns, except for this side. When the 4x4 areas are coming together, what I should say is that it's a non-shape-shifting scramble where this is moving 90 degrees. So I'm free to go all around the puzzle like this. 180 degrees in this one direction. What I'm doing is I'm just separating out the areas that will eventually get bandaged together when I do a 2x2 solve. So we're just going to enhance the scramble as much as possible. A little bit more over here. The next thing that I do to enhance the challenge as well is I'm going to start to move 90 degrees in this direction and just do 2 movements over here. The reason why I'm doing that is because I can still function with these. So I'm doing 90-degree turns here and doing 2 Fs over there. That way I haven't restricted these kind of moves. So still keeping the challenge up. Double turning over here so you can see that I can do a lot over here. So too, I'm going to pick a side. Now understand, this doesn't shape shift. However, it does bandage. So just like you can see these are bandaged here, when I turn this up over here, I didn't shape shift it by pulling it up, but I did bandage these so that when I turn this, I can't get to it. However, when I double turn like this, I haven't bandaged anything here, so I can still do this. And that's really what I'm doing over here. I'm just kind of trying to hold my, keep myself from bandaged as much as possible. Maybe I'll do this here too. So before I go for the final scramble, okay, so I think the majority of them have a nice little bandaging process to that. Okay, once I do that, now I scramble it as the base puzzle, which is a 2x2. So the 2x2 scramble ensures that I've really mucked it up and I've really put myself into dire straits. And there's no escaping the true scrambling of this. I've got pieces that are bandaged together that don't belong together. Chaos ensues, dogs living with cats. Who knows what kind of apocalyptic situation we're going to get into. So too with here. Now I can just do a simple 2x2 scramble. Some of them are bandaged, some of them are not. Okay, so there's no way getting around it. We have ourselves a nice little scramble. Okay, we're fairly bandaged. So again, my whole premise here is that it's the same type of challenge. Just this one is shape-shifted, this one is not shape-shifted, but the same kind of challenge. The strategy that I use when doing a floppy is you first solve it based on the base cube. The base cube is the smallest layer, which is the 2x2. 2x4x4, the 2x2 layer is the smallest, so I'm going to solve it as a 2x2. What has to be remembered is I'm going to ignore all the mess in the middle and just solve it based on the terminal corners. It might be easier to visualize with this. So if I were to solve it based on a 2x2, I'm only going to do it based on the terminal corners. So if I were to focus on the green, well, I'll look for the green and red, which is, oh, I don't know. And again, it's a green and red corner. So right over here, you can see green and red. So this is going to be one of those videos where I do 2 tutorials at the same time. So that's over here. Now all the way across here is going to be the green and white. So I'm looking for the green and white. Here's the other one, so that's going to be the green and yellow. So that's going to come over here. So just bear with me with this because I'm making a point. Alright, so here's a green. The final green is a green and white. Here's a green and white over here. Turn. Okay, so this represents my green side. Doesn't look much solved, but that does represent the green side. I'm going to continue my 2x2 solve by putting the the blues in. This blue is the only one that's up. I can do a Sunni by having this blue coming out at me. Again, this is just 2x2 solve. RU, RIU, R2U, RI. We have 2 corners that are in. I'll move them in the proper place. These need to do a corner swap. 2R, U, 2R, UI, 2R. Turn the puzzle. 2R, UI, 2R, U, 2R. And there you have it. It's in. I really like doing floppies. They're a lot of fun. Anyway, so this is my base 2x2 solve. Alright, so that's what I'm going to start off with this. Do your base 2x2 solve. And it doesn't matter. We can do greens again. You can see a little more scramble. Here's a green, orange, and white. Look for the other green corner, namely a green and orange corner. Here is a where did I put it? Green and orange corner is right over here. So let's just move that down, bang. Now I'm going to look for the green and yellow. It's right over here. So just going to RIDA, RD, RIDA this one where it needs to be. So that's where it needs to be. The final green, it's right here. Just have to move it in. Okay, so you can see I've got the first side, the first green side, turn it upside down, and I'm going to do the blue. Alright, so I got to rotate these blues up, RU, RIU. You can do any 2x2 strategy that you want. This is up, the only one that's up. This is facing out at me, anti-Sunni. I'm not getting too much into detail with this because this is just a 2x2 solve. If that was too fast for you, then, well, slow me down, but basically I'm doing a 2x2 solve. So I've got all these rotated up, these two corners are in, so I've got to corner swap these two to move this red to here, 2R, U, 2R, UI, 2R, turn the puzzle, 2R, UI, 2R, U, 2R. Okay, so I've got these in and these in over here. Now, I guess I should pause. If you have this puzzle and don't know how to solve a 2x2, then this might be a little frustrating for you because I'm moving very fast. So if that's the case, send me a message and I'll get more into detail about how to solve a 2x2. But you really need to know how to solve a 2x2. If you did, then you'd understand that what I did with these corners is I solved them as a 2x2 using algorithms that I didn't mention here, but are known algorithms of how to solve a 2x2. I did a corner swap, I did a Sunni, so if that was too fast, let me know. It was based upon the premise that you know how to solve a 2x2. So now the next part is we've got to put all of this junk in. So how do we do that? Well, the way that we want to do that is we need to take all of these edges that are coming out at us and move them down. And the way that we're going to do that is I'm first going to look to see how many of them are placed up. So this is up, and this is up. This is the only one that's facing down, that's facing where it needs to be. So because I have 3 that's up, I'm just going to go like splat. So you can see how closer we are to the flat shape. We have this over here. I've got these 2 that are up. I'm just going to turn this over here, and I'm going to cause these to come down by flipping them. And that's with, well, a parity algorithm from a 4x4, or the Red Bull algorithm. What that's going to do is that's going to flip that down. That's 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. Now I should point out, the reason that I'm doing this is I'm getting it back to its native shape, and I'm doing that because I want to free up the bandaging as much as possible. As long as this is facing up, I can only do this 2x2 move, but if I get it facing down, I now have this move available to me. So by doing this, by returning it to its native shape, then I can free it up. So another Red Bull here. So now we've freed that up. So we're going to hit this one over here. So it doesn't matter where we're looking at it. I think what I'm going to do is I'm going to have the red, the orange, and the white on the top. And you know how I said that there's this configuration somewhere rotated up? The equivalent to that is these guys here are like this over here. So any color that's not white or yellow, think of it as being rotated up. And the reason why you think of it the same way is because it does the same kind of bandaging. As long as that's up, I can only do this move. I can't do terminal moves over here. So too, as long as these colors are up here, I can only do this move. So far there's no difference in the structure. So I'm going to do the same thing. How many in this plane is, quote, up? We've got 1, 2, 3. I've got 3 that are up, and only one that's down, which is this. So I'm simply going to move it down like so. Bang. So you can see I've already freed this up. I've only got 1 that's rotated up on this side. I've got 1 that's rotated up on this side. So what I'm going to do is I'm going to put them next to each other, like so. Turn it like thus. And now I only have these 2 that are rotated up, and I can Red Bull it and then put these back in over here. So far it's exactly the same. Now you might get slightly other complicated type situations with that. It's just going to be a matter of positioning things. But in any case, let's do a Red Bull algorithm and bring this down. 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2r. So you see, I did nothing different. I simply returned it back to this shape. So now everything is freed up. There isn't any bandaging with this. Now, to those that are struggling with this puzzle, there are going to be some configurations that I didn't happen to get into when I was doing the scramble. So if there is one that you see, let me know. But a lot of it has to do with positioning things so that you can put two that are out next to each other so that you can do a Red Bull algorithm to bring it down. Here's an example of something else that you might see. You see that we have our 2x2 solve done, and now we have to start moving these things in, but you can see that they're not exactly in a symmetric way. So we look here, we have two that's up and two that's down, so we can just move them. So we want to start moving things next to each other. So I want to move something next to here. As I move this here, I can't, this separates this out over here. So you're going to find things that are kind of at right angles to each other. And as long as this is here, and maybe I can move one in here, but you see this is at right angles, so I can maybe move it like this, and move it like that, maintaining my 2x2 solve. So I've got these two next to each other, but this is at odds with it because it's crossed right in the middle, so I can't do a Red Bull algorithm. And this is at odds with this over here too. I could move this over here, but still this is a problem. So when you're kind of at odds with things, what you need to do is you need to move this away from being at right angles. The way that you can do that is to take these whole clumps and just do a corner swap. If you do a corner swap, this will move here, and that'll take that out of that. So that's all that's really referring to. So I'm going to take this, I'm going to move this here so it's in line, and let's go ahead and do a corner swap so that this will now be parallel to this. 2r, u, 2r, ui, 2r, turn the puzzle, 2r, ui, 2r, u, 2r, turn it back. So now you did mess up the 2x2 solve, but you're just a corner swap away from getting it back. But now look what you have. You free this up so we can Red Bull this, then Red Bull that. Or I can say I've got three that are out, one that's in. So I move this over here. So I'm in that same configuration. So this can be Red Bulled and this can be Red Bulled, and then you're okay. Now, although I did not show that on this puzzle, it's exactly the same configuration. So what I showed you was not a unique issue of a non-laminar problem with the bandaged version of the 2x4x4. You can get exactly the same thing with this coming up at right angles to each other. So far that's no different. I didn't show it on this puzzle, but trust me, you can get it there. So now that we have that, the next step is just, well, it's really the same, because remember the premise is that there is no difference in the solve. What I'm going to do is sliding U techniques to get all of the orange sides up here, starting with the centers, move it into here with the 2R, slide it to the L, 2L, slide it back to the right, 2R, slide it back to the left, and 2L. So we've got that. And then what I do is I just go through each of these yellow pieces rather, and put them in their respective place. This belongs here. So I'm going to move this in here, I'm going to move this in. Oh, got the wrong one. It's this one. So I'm going to move this in over here. 2R, slide it to the left, and it's going to be the terminal left, 2L. Slide it back to the right, middle right, 2R, slide it back to the left, middle left, 2L. And that's all I'm going to do with this entire side. It's super, super easy. It's no problems bringing it in. I'm actually going to take this one out too, because it doesn't belong there. Swing it over here. So this first side is no worries, no problems at all. So this blue, I'm going to position it to where a 2L can bring it in, swing it to the right, 2R from this side, swing it back to the left, 2L, swing it back to the right, 2R, and you see that that's in. And now for the green one goes here, 2L from the middle, swing it to the right, 2R, swing it back to the left, 2L, swing it back to the right, 2R. So this is really more the busy work portion of the solve because it's not really particularly challenging. You're just placing it. I guess I wouldn't call it busy work. It's kind of fun anyway. Kind of relaxing, almost like meditation, to see order being created out of chaos. Whoop. Unless I'm talking too much and lose track of what I'm doing. Turn here, 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 here and here. Sorry about the here, 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 and here, but basically it's the same concept. The green is going to come over to here, 2R, swing it to the left, 2L, swing it back to the right, 2R, swing it back to the left, 2L. Okay, so we have one side done. So I'm going to show us the same thing over here. So why don't we go ahead and do, whoops, do the yellow side. I'm going to take these. Yep. I'm going to do that first, just, you know, for the sake of it. So I want to swing this all the way to here. And this is easy. I can coordinate it with this center. Bring the center down. Well, actually, because I don't really care about the centers, I'm just going to swing it up like that. Now we're just going to position all the other orange edges. Let's find one here. This blue belongs here. So we're going to position it all the way around here so that a 2R can bring it in. 2R brings it in, slide it to the left, terminal left, 2L to take it out, slide it back to the right, 2R to bring this back in, swing it back to the left, and 2L. So that's what I call the swinging U technique. It's kind of like you're playing ping pong. You're going back and forth. So this red one will come over to here. So 2R serves it, knocks it to the left, 2L returns it, knocks it back to the right, 2R takes it back to the left, 2L moves it back to the right. Maybe I'll call this my ping pong technique or tennis technique. This red one comes to here, 2L to move it in, swing it to the right, 2R to take it out, swing it back to the left, 2L to bring all these back in, swing it back to the right, 2R to bring that back in. Now this orange one will go where orange has to go. So I'm going to swing this in. Now I'm going to do something a little different. I'm going to swing both of these out because none of those belong here. So I just did an entire 2M, swing it to whichever side, doesn't matter. Do a 2L, swing it back, do another 2M, swing back here. The reason why I did that is I had two orange ones that were in the wrong place. Now I brought it down here, which puts us ready to do what we got to do. So this comes here. Again, my premise being is there's no difference within the solve strategy whatsoever. This orange is going to come here, 2R, swing it to the left, 2L, swing it to the right, 2R, swing it to the left, 2L, swing it back, and we are almost done. Okay, this blue will knock this bad green out. Turn, turn, and one more to here. Okay, so as you can see, we have the same configuration, done the same way, no difference at all. So turn it upside down, and now this is pure cuboid strategies. What I'm going to do is I'm going to line these centers together. There's a couple of different things that can happen, but I'm going to do corner swaps to put them in. So we're going to try to match these in. I'm looking for a color here that's the same as this. It's not this, it's not this. It looks like there's nothing, no corner swap is going to put them in. When that happens, what I have to do is I have to just do a swap of two edges, because if I swap the two edges, this orange will be here to match with this. Doesn't matter which ones, but swap it you shall. So that's going to be 2R, 2U, 2R, 2U, 2R, 2U. The reason for this is because you're going to be doing corner swaps to line these up. But if you don't find the configuration that you need, then you have to rearrange these a little bit. So that corner swap, rearrange it so you can see this orange will come here when I swap them. So let's see what happens when I do that. 2R, U, 2R, UI, 2R, turn the puzzle, 2R, UI, 2R, U, 2R. Okay, so you can see that this is brought in, which is good. Now, so I did take these edges, these corners out, but that's okay. My premise here is I'm solving this now as a domino. I've reduced my floppy to a domino, and by doing corner swaps and edge swaps, I should be able to get it in. The problem is, this was not a domino, this was a floppy. That's the parity of this puzzle. This puzzle had floppy parity, as opposed to domino parity. That's the overall structure. Just because I reduced it from one parity to another doesn't mean I'll be able to solve it as that final parity puzzle, which would be a domino. Just because I reduced it from floppy to domino doesn't mean I can solve it as a domino, and if I can't use domino moves, which means I have a parity. If this were a domino, one would be in, or all would be in, but not two. I have two that are in. because I have two that are in, I can't solve this as a domino anymore because I have a floppy parity, which means I have to take it out of a domino position and do moves that a domino can't do. That's what I mean by a floppy parity. The parity of the puzzle is basically changing from one type of puzzle to another. So that's that situation. What if I tried that with this one as well? So I'm looking around and I'm seeing, okay, what can go in? Once again, I don't see any corner here that can go in, so I have to flip them in. How can I do that? Well, I need to move this blue to here so that it can match with this. So I'm going to do an adjacent corner swap. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. So actually was an adjacent edge swap. So now this blue can come over to here. So we should be good. So we'll go ahead and do a corner swap to get this blue in. 2R, U, 2R, UI, 2R. Turn the puzzle. 2R, UI, 2R, U, 2R. So you can see that this blue is in. Now in this situation, these are all out. So this is not a parity. This is not a floppy parity. But it could have been. It could have easily been a floppy parity if when I put this in, it looks something like this. So you might have a situation like this where this is in and this is in. So this is the floppy parity. If you just had one in, putting it to the left and doing another corner swap would put all the edges in. But when you have two that are out, you can't, because every time you do that, you're going to be chasing your tail. This will come in, but then you're going to have both of the greens and the blue. So that's going to be a problem. So this is the floppy parity, and how do we get out of this? Well, the first thing to do is make sure they're opposite each other, because then we're going to deal with these two. And we're going to use a Red Bull algorithm to do that. Right?
Yeah.
Yeah. So the way that you're going to do that is if I move this up here, and I do the Red Bull algorithm, this blue will come here, this red will come here. When this blue is here, it'll then accept this blue, and it'll be lined up with it. So in this position, you do the Red Bull algorithm. Now I should say, this is not how I used to do it. I used to do it where I would do 3 different Red Bulls, and it would always work. A viewer actually suggested to do it this way. They said, why are you doing that? Why do you do 3 Red Bulls when all you got to do is set it up over there? I took a look at it and said, you know, you're right. You're absolutely right. So this is a far better way to do that, which is why this is an exact reason why crowdsourcing works. Anyway, so do a Red Bull with this. So that's going to be 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. And now we simply move this back up, and you can see this is in, all of these are now in. So all of these edges are now reduced. This is the same thing. There's no difference with this. The only difference is that I want to make sure that these aren't next to each other. They're opposite each other. So I'm going to do an opposite edge swap. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. And now we're going to do the same thing. If you get it like this, then you're going to take this red, and you want to put it opposite this red. If I move it up, like so, I didn't shapeshift it, but the concept is exactly the same, laminar or not. And we're going to flip-flop these two, so that this will be ready to accept this red, and this green will be ready to go with this green. So 2R, 2B, 2U, L, 2 up, RI, 2 up, R, 2 up, 2F, R, 2F, Li, 2B, 2R. And now this simply comes up, and bang, these are all in. So you couldn't do that with a domino. The domino form has that domino parity. That just means what that is. So you had to do all this shape shifting as you would a floppy. So that's why I called it a floppy parity, because you tried to reduce it to a domino. Now the rest is you simply do a corner swap using this. So these two corners are in. This needs to flip with this, so we just do 2R, U, 2R, UI, 2R. Turn the puzzle 90 degrees, counterclockwise, 2R, UI, 2R, U, 2R. All of the edges are in. Now it's just a matter of putting, all the corners are in rather, edges, an opposite edge swap. We move the red here, 2R, 2U, 2R, 2U, 2R, 2U. An adjacent edge swap, we'll move these in. 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R, and this is solved. So too, same thing here. Let's go ahead and move our corners in. This blue will come over to here. Corner swap, 2R, U, 2R, UI, 2R. Turn the puzzle, 2R, U, 2R. Okay, you can see in this case, all of these are in, We just do an adjacent corner swap. 2R, U, 2R, U, 2R, 2U, 2R, 2U, bird fight, 2R, U, 2R, UI, 2R, and it's done. So, in this way, what I showed is that there's no difference in the solve. There seems to be a little bird party out there. There's no difference in the solve between the bandaged 4x4x4 to 2x4x4, and you can bandage your own 4x4 with this, and an actual 2x4x4. The solve is exactly the same. The only reason to buy this puzzle is because you like the aesthetics of a collection, but if you just want the challenge, this is exactly the same. I don't know what Twisty Puzzles Forum meant, or the Twisty Puzzles Museum meant, by calling this a difference or a more complex strategy. My contention, and what I think I've proven, is that it's exactly the same strategy. You just have to understand what is the equivalent to shape-shifting. In this case, instead of shape-shifting, it's just bandaging without shape-shifting. Anyway, if there's any other suggestions of what was meant by that, or any other questions regarding this puzzle, let me know. Thanks for watching.